Good day, everyone. Welcome to the presentation for the geometric design for the upgrading of Oliver Tambo Road in Bloemfontein. The project details, the name of the street or the road is Oliver Tambo Road in Bloemfontein Free State in South Africa. The coordinates are given there on the presentation. The client is Mangaung Metro Municipality. The project objective for this current project is to upgrade the existing two-lane dilapidated road to a four-lane divided road, and the conditions of the existing site is that the road currently existing is dilapidated and there is also no stormwater management system. Over here we have the site overview. The location of the proposed road is interconnecting with the N6, and it's on the southern part of Bloemfontein. The actual introduction of the project, the client is Mangaung Metro Municipalities, and they propose to upgrade the existing road to a four-lane divided road due to the growing demand of infrastructure in Bloemfontein. The proposed road is to be upgraded to a major arterial road because it's moving towards the center of most of the services in Bloemfontein, and also the road acts as a link between the N6 and the N8, which leads to Brandfisher. The purpose of this presentation is to outline the structural design of the pavement, the methods that were involved in the geometric designs when we were using TRH17 and Autodesk Civil 3D, and then the conceptual drainage design using the Sandra drainage manual, producing the design drawings using the Autodesk Civil 3D, and also doing a comprehensive report. For the design of this project, we had to consider the topography, the geotechnical information, the environmental information, the climate, the safety of the public and the environment. We also had to look at the types of traffic, that is the traffic loading, and the existing cadastral, which is going to govern our geometric design, and also the existing services around the proposed. For the design approach of this project, the following documents were collected to be used for the design of this project. We have to use the TRH17 for the geometric design of rural roads, TRH4 for structural designs of pavements, UTG5 for the geometric design of urban collector roads, UTG2 the neighborhood planning, which is the red book, and also considering the municipal standards, and also the drainage manual from Sandra. For the structural design of this pavement road, we had to come up with some of the estimations because some of the information was not available. The road category, based on the information that was observed on site, the road is category B. The bearing capacity was estimated to be tandem because it's a combination of roads where there is the use of trucks and also small vehicles. The analysis period was to be for 30 years, and the structural design was going to be for 20 years. The estimated ADT assumed was 4,500 vehicles per day, and then based on the calculations that we did, we found that we need to upgrade to a four-lane divided road. The bearing capacity of the road was calculated to be 3 to 10 million standard axles, which led us to a road class of ES10. The climate conditions of this area of Bloemfontein is dry conditions, and the estimated road width in terms of UTG2 is 3.5. Based on the calculations and the estimations made above, and also on the CBR information that was provided as shown on this table, the layer works were determined, and then we have concluded that we're going to be using the surface treatment with graded crushed stone as the base, and then the natural gravel, which is the G5, as our sub base. The proposed road, we were to upgrade it to be a 60 km/h speed limit. Minimum radius is to be 110. Nominal crown of the road was going to be 2%. Super elevation rate based on the speed limit was going to be 4%. For the vertical alignment, we were going to be accepting the maximum gradient of 8%. The minimum gradient for drainage considerations, we were going to accept 0.5. Critical length of grade was going to be 170 based on the UTG and the TRH 17. The minimum K value was supposed to be 16 and 16 for the seg and the crest, and then the minimum curve length was going to be high. For the geometric design of this project, we used AutoCAD Civil 3D. The outputs that we were going to have was to produce the horizontal alignment, the vertical alignment, multiple section views, and then the cut and fill volumes, provide the mass hall diagrams, and also give out the detailed design drawings. Before we began with our design, we had to make sure that we have the cadastral information, make sure that we have the survey data, and also check with the municipalities as per the recommendations of the project. For the historic information, the Google satellite information, for the street view. For the geometric design steps of this project, we had to start by making sure that we open a clean file, and then we import the cadastral, and then we import the points. Then we create the surface of the project, and then we create the polyline. Then we follow by creating an alignment from the polyline. Then we create from the alignment the long section of this road to see the natural ground and the topography, and then we had to create the design profile on the existing profile, and then we had to build an assembly so that we can be able to create the corridor. We calculated the super elevations and then created the left and the right profile. Then we had to generate the sample lines and then create the multiple section views from the sample lines. Then we have to create the material list, generate the cut and fill volumes, and then also create the mass hall diagrams from the design. For the typical cross section of our road, after we had done the structural pavement design, we had established our layouts, and then we had to look at our cross section, the type of cross section we wanted to do. We looked at the rainfall data. We also looked at the climatic conditions based on the wind and value. We also had to collect the information of the topography, just so that we can make sure that the road does not cause problems for the drainage of the road or flooding of any houses that are in existence. From that information, we have determined that we needed to upgrade our road to a 4-lane divided road, which is divided by a median, and then which is going to also be a camber at least 2% slope towards the stormwater channel. And on the sides of our road, we had proposed, as can be seen over here, we had proposed to have at least the cache pits on either side of the road, and then have our stormwater cross our road back into the center of the road through a pipe that is proposed at the center of the road due to the cost limitations. And then we were going to have this water move into our pipe network and then go all the way into the daylight point. Yes, for our horizontal curve information, we developed a spreadsheet as shown on the table below. And on this presentation, what we had to do in the spreadsheet, we had to collect the information of the deflection angle, the PI change, the radius, and also the speed limit, so that we can be able to calculate for our super elevation. And also, one thing to note, what we had to do is to convert this information, the deflection angle to radians, since we are using the trigonometric function in Excel. And on the table below, we have the components over there, which is the information that we were calculating, the abbreviations of the components, the output information in meters, unless it's indicated somewhere else. And then on the far right, we have the calculations of the horizontal alignment components, which defines the Excel sheet formulas that we inputted in our calculations here, so that we can get our values. To verify the information of our vertical curve calculations, we had to do the manual calculations just to verify if our system is actually producing what is supposed to be produced. We collected the information. The first curve that we used was a curve with a crest, and then we used the information of the point of intersection, the tonnage and the elevation to determine the beginning of vertical curve and the information of the end of vertical curve. For additional information, what we had to consider was the safety of the road by making sure that there is enough road signs on the road. There's also pedestrian considerations, and then there's also environmental considerations. And the safety requirements were based on the National Road Traffic Act of 1996. Here it's the presentation of our mass haul diagrams that was produced from the design. And on this part of the project, this is the output that we got when we were calculating for the mass haul diagram. This information is showing our material take volume. During the design of this project, what I have learned under the mentorship of my mentor, I have learned the importance of road classification and the functionality of the road hierarchy. And then also I understood the design standards and guidelines and how they are applied in real world problems. And then I got to gain confidence in my engineering designs. And then I've also picked up on the skills of project management and also being able to manage the time. I also had to work on myself to be able to do the project presentations and also work on my communication skills. And then I had to learn how to do infrastructure projects and the importance of coordination. And then I also got to have a practical experience of solving real world problems. And then I also got to master most of the skills that I thought I used to lack by using Civil 3D and the other softwares that I've tried while doing this project. Thank you.